So, last lesson we looked at the scenario, we threw a normal fair die 40 times and we wanted to know the probability of getting 10 or more 6s. We said to start with that this die, if x is the number of 6s that we get, we said x was binomial. What was going to go in the brackets for the binomial thing here? What's the first thing that always goes in the brackets for a binomial?
The number of trials.
The number of trials, n, which was 40. And the second thing that goes in there,
6.
which is p, the probability of success. Okay? And we said last time that the conditions we are using, as np is greater than 5 and nq is also greater than 5, we can approximate this by the normal distribution. And it's np that goes in there, and it's npq that goes in there. So last time we came up with a normal distribution, and what were our two parameters for our normal distribution? Have this last time. Liam, what did we have last time? What were the parameters?
Can't remember.
You've not got it with you. NP, what was that, someone?
6 2/3.
Yep, 6 2/3. And NPQ?
5 and 5/9.
5 and 5/9. Yeah, that's correct. That's what we had last time. Okay? Right, what I want to do now is consider this question. What is the probability that x equals 3? And I want to do this two ways. I want to do it first off using the binomial distribution. And secondly, I would like to do it using the normal approximation. Okay, so we're going to do this question twice and we're going to compare the answers that we get. So, first of all, doing the binomial distribution. What is the rule, or the formula, whatever you want to call it, for the binomial distribution's probability? Something you should be able to know, should be on the tip of your tongue. What is the formula for the binomial probability thing?
NCR.
Yep.
N's P's the R.
Yep.
Times Q's the 1. N minus 1.
Yeah, that's right. Okay, everybody should be knowing that on the tip of their tongue. Everybody should have that straight away. So, here we go. We have n is 40. And if I want the probability of 3 successes, r is going to be 3. I have my p value to my power of r, my q value to the power of n minus r. So if you can work that out on your calculators, give me a decimal, see what you get. Is what I have down here. Okay, so that is an exact answer to this. No approximation needed, used rather. That is an exact answer. But if we were going to use the normal approximation, again, what we wrote down last time, I put a little n down here to show that what you're doing. We are doing this now using the normal approximation. What if you're saying what's the probability that x equals any specific value in the normal distribution, what is your answer always? 0. So that isn't helpful. So we have to pretend, if you like, or imagine that 3 goes between what values? Where does 3 start and where does 3 finish?
2.5.
Yeah, 2.5 to 3.5. Okay? That is really what we are doing. And at this point here, we have used something called the what? Two words go together, both start with C. Continuity correction, yeah. So we've used here the continuity correction. Okay. Actually, I'm going to change that n over there to be a b. It's a binomial distribution of 3. For the normal distribution, we are looking between 2.5 and 3.5. Okay, so if we're going to do this, we've got our normal distribution parameters up at the top of the screen, up here. How would I go about working out that probability? Probability lies between two values, something we did before the summer break. Split into two and do one away from the other, yes. So, we did have this written down before as a red box rule. If you're doing the probability that x lies between A and B, you do the probability x is less than... It'd be great if more people could give answers. X is less than B. take away the probability x is less than a. Okay, so that's like what we are using here. So the probability x lies between two things. So this question here becomes the probability x under the normal distribution is less than 3.5. Take away x from the normal distribution is less than 2.5. Is that good or bad that we have less than signs in here? Good, yes, okay, because our tables are less than tables. So, Chris or Liam, what do we do next in these normal distribution questions?
We use phi.
We use phi, correct. And what always goes in the brackets when we are phi-ing?
X minus mu.
X minus mu. Mu we had earlier is 6 2/3 over the standard deviation, yeah, which is a square root of the variance. So it's a square root of 5 5/9. Okay, so that is what we get for the first bracket. We need to do the same thing over here, but put a 2.5 in. The mu and the sigma will remain the same. So the next step is to work out the value of each bracket. And then use your tables or your calculators to get answers. So can I leave you just to finish that bit off and see what you get and whether you come up with any problems? What are the numbers in the brackets? Have I got to bribe you lot with fruit gums to get answers out of you again? As soon as I say that, somebody picks up a calculator. Right, what's the value inside the first bracket?
1.34.
Say it louder.
1.34. Wait, do I get a fruit gum?
No, because it's not the right answer either.
19 or negative 19.
Yeah.
So you're saying the negative something.
1 minus 5.
Okay, so yeah, you've jumped one step ahead. Yeah, that is a negative value in there. It's negative 1.344. We'll come to the one on the right in a minute. How do we deal with phi's of negatives?
5 moved from z is 1 minus 5 z.
Yeah, okay, so there's a red box rule. I've used k, but yeah, phi of negative k, remember, is 1 minus phi of positive k. So you can use that in there to rewrite that one there. That's the first bit. Anybody got a value for the second bracket?
Minus 1.768.
Yep. So I've used that red box rule over here as well. You're all beavering away, fair enough, but as you're doing it, what's happening to the one here and the one here? They cancel, yes. Positive one and there's a negative in front of that one. They disappear. Actually, what you get here is a negative negative here makes that one a positive. And this one here, it still has a minus sign in it. So if you want to write it down clearer, you can write it down like that. Right, has anybody got the value of phi of 1.768? From tables or calculators?
0.9615.
0.9615 is what I have a note of here. Was that a sage nod that you had got that, or were you just pretending you had got that on your calculator? Bit of both. Okay, so can you give me this? So can you give me this one here yet?
9105.
9105. Whoever said that was correct, and they saved Mr. Hawkes a bit of bother over there. So then you do the taking away, and we get an answer of 0.0510, and that is our approximated answer using the normal distribution. And the one we had earlier, our exact answer was 0.0538 to the same thing. That was our exact answer using the binomial distribution. So, those answers. Any comments comparing those two?
Pretty different.
Do they agree to any degree of accuracy? Yeah, they agree to one significant figure. Okay, they agree to one significant figure. Okay. But as far as your exam board is concerned, As long as those conditions are met, then that is good enough. That is going to be good enough. Okay? Right, next, just a few other quick things. These, I'm going to do a little table here of binomial probabilities, and on the right, our normal approximation probabilities. Okay? So, if our question was, in the binomial, find the probability that x is less than or equal to 7, how would we rewrite that using the continuity correction thing? How would we rewrite that in terms of x and a probability for the normal distribution? 7.5, yes, that's right, okay. Because we've got to include the 7, so that would become 7.5 over there, that's correct. Probability x is greater than 5. X is greater than 5. What would we do?
1 minus probability that x is less than 4.5.
Let's forget about the 1 minus first of all then. We'll come on to that stage in a minute. If I stuck with a greater than sign, what would I have to write down here? Got to be greater than 5. It cannot therefore include 5.
Oh, 5.5.
5.5. And yet we do not like greater thans, so then you would turn it around into 1 minus x is less than that. 5.5, okay? There's another one. If it was a binomial question asking the probability 3 is less than or equal to x is less than 7, what would that become if we were turning it into a normal question? First of all, let's just try and write it down in that format. What numbers would I put in here? 2.5. Let's just stop there a minute, okay? We've got to be able to include 3, so we have to go down lower than 3, so yeah, that is 2.5. The other end, strictly less than 7. 6.5, yeah, we are not allowed to include 7. Okay? How would you then go about doing that if I want to rewrite that now? Using the red box rule we had earlier, probability it's between two things. How would I rewrite that as my next line if I was doing that in the normal distribution?
Probability x is less than 6.5 minus probability x is less than 2.5.
Yeah, that's right. Okay? And as long as you're totally comfortable on those things, how you move between the binomial and the normal approximation, you remember any other sort of red box rules we've had today, you should be fine on this work. So there's no more teaching on this now, we're going to get stuck into some questions on this.